right, so we know that there's a way to find our coefficients by doing your big C and your N and your R's. There's another way you can remember these, and this is called the Pascal's triangle. So if you were actually trying to think of Pascal as this guy, sorry, wrong Pascal. My bad, little whatever you are, little varmint. Wrong Pascal. So Pascal's triangle starts with a 1 on the top, and then you go down to a row of 2 terms. Well, each of those are 1s. You go to a row of 3 terms, and then 4 terms, 5, 6, 7, 8, on. The top row, we actually call this our 0th row. I know, kind of weird. Never heard of the word 0th. This is your first row, so your 2 1s is your first row. Then you have your second row. And this will make a little more sense here in a little bit why we call them the 0th, 1st, 2nd, 3rd, and on, as you go down. Now, if you notice, each number that is in between on the row below can be found by adding a 1 plus a 2. Gives you a 3. If I want to find this 3, that's a 2 plus a 1. Down here, on another row down further, that is a 4 plus a 6 gives you 10. If you want to find this 21, well, that is just 6 plus 15 gives you 21. And that pattern just keeps going down and down and down. Lovely pattern, lovely pattern. It's also very useful if you do remember this, because I know we had a couple examples where we had this row where our coefficients were a 1, 4, 6, 4, and a 1. And that's our 4th row. Well, I feel like that 4 kind of coincides with something that maybe we did on our example. Oh, I don't know. Maybe an expansion of something to the 4th power. Very interesting, very interesting. So this would be anything that comes to the 4th power. These would be your coefficients. If you have a 1, 3, 3, 1, that'd be anything that goes to the 3rd power, and so on and so on. So if you, I don't know, if you remember those, or even if you write it out, that may help you figure out your coefficients even faster than doing the old C way. So let's try to find our 7th row of Pascal's triangle to find our binomial coefficients. So our 7th row, shows up as, here's our 4th, here's your 5th, your 6th, and your 7th. So we're going to list out our 7th row. And our 7th row ends up becoming a 1, 7, 21, 35, 35, 21, 7, and a 1. Notice that your first and your end, or your first and your last number is always a 1. Now, if we want to find out what our 8th row is, well, that's no biggie. We can just start with a 1 out here, end with a 1 out here, and what we're going to do is to find the number that goes here is just take 1 plus 7 gives us an 8. The number goes in between 7 and 21. 7 plus 21 is a 28. 21 and 35 gives us a 56. 35 and 35 gives us a 70. And now we're going to start working back down. So there is a pattern here. Obviously, once you get to the middle, then your numbers start going back down the other direction. There's also something else that's important to know. If you have something to the if you have a 7th row, that means you have something to the 7th power. Well, if you have a 7th power, you're going to have 1, 2, 3, 4, 5, 6, 7, 8 terms. Okay, 8 terms. If you have an 8th row, that means you're going to have something to the 8th power. You end up getting 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. So keep in mind, whatever your expansion is, you always have one more term than whatever your degree is. That's a little helpful hint